In this short video, we'll be discussing about the dimensions of stress, pressure, elastic modulus and energy density. Know that all four quantities are different, but they all have the same dimensions. What is stress? So if you say stress is nothing but force per unit area. It's different from pressure. Force per unit area. It is called stress. See, two examples I'll give you. Suppose you have a cylinder and you want to lengthen the cylinder. When you want to lengthen the cylinder, what you will do on this surface, you will apply force on either sides to stretch this. So in this way, this force is acting perpendicular to the area. This force perpendicular area is called stress. Sometimes, suppose just imagine a cube or a cuboid and you want to slide. When you apply force tangent to this surface, it will try to slide one surface over the other. Here the force is acting parallel to the surface. So stress is nothing but force per unit area. It could either be perpendicular to the surface or it could be parallel to the surface. So dimensions of force we know. So stress, the dimensions of stress is force. The dimensions of force is dimensions of stress is actually dimensions of force by dimensions of area. So dimensions of force is mass, length, time power minus 2 by area, which is measure of length into breadth. Both are length. Breadth is nothing but length measured in another direction. Length into length is L square. We are getting m L power minus 1 T power minus 2. These are the dimensions of stress. Let me come to very specific about pressure. Pressure is very clear. Pressure is thrust by area. Thrust means the force acting perpendicular to the area. So from a class stress, pressure is nothing but force acting perpendicular to the area by area. Again, thrust is nothing but force, right? So that is also ml T power minus 2 by L square. You will get m L power minus 1 T power minus 2. So the dimensions are same, but they are not the same. So stress is different. Subclass of stress, you can consider it to be a pressure. What is elastic modulus? Before elastic modulus, I would like to introduce you strain. What is strain? Strain is nothing but change in value to the original value, because when you apply this force F, the length of the cylinder changes. Suppose the total length was this, so this much length has changed. So strain, the lengthwise strain is change in length to the original length. And suppose when you try to compress from either side, the volume increases. You squeeze. Suppose if you try to take a sponge ball inside water, it gets compressed. So in that time, the change in volume to the original volume is called volume strain. This is linear strain, this is volume strain. So the change in value of one quantity to the original quantity we call strain, or that ratio. Suppose volume is in meter cube, means change in volume will also be in meter cube. So their dimensions cancel out each other. So strain, learn this. Strain has no dimensions. No dimensions. So what is that? Then if that is the case, we are introducing a new quantity called elastic modulus. Elastic modulus. Elastic modulus is the ratio of stress to strain. So then dimensions of elastic modulus is dimensions of stress by dimensions of strain. Dimensions of stress is m L power minus 1 T power minus 2 by strain has got no dimensions. So 0 dimension means it's not 0 actually. M power 0, no dimensions, right? So let me write m power 0, L power 0, T power 0. So all power 0 is 1 actually. So the dimensions is m L power minus 1, T power minus 2. So stress and then pressure and then elastic modulus, all are having the same dimensions, but they are all different. The other point is this. What is that? Energy density. Energy density. Density is mass by volume. Energy density is energy by volume. Energy by volume. So dimensions of energy density is dimensions of energy by dimensions of volume. Dimensions of energy is m L square T power minus 2. This we had discussed in the introduction to dimensions. Maybe you just go over there and find out to know the dimensions. Volume is L cube, because volume of anything, suppose you take a cube, L cube, you take a cuboid, L B H. L is a length, B is also a length, H is also a length. Length into length into length, length cube. When you bring this up, so what you are getting is m L power 2. When this 3 comes up, minus 3, 2 minus 3 is minus 1, T power minus 2. So these are 4 quantities: stress, pressure, elastic modulus, and energy density. All are having the same dimensions, which is m raised to 1, L raised to minus 1, and T raised to minus 2.